Today, we're going to start chapter 9. We're going to talk about developing formulas for triangles and quadrilaterals, section 9.1. So for the most part, some of today should be review, as you've already done some of this back in junior high math, some of the algebra. We did some of this early on in chapter 1. But developing formulas for triangles and quadrilaterals, section 9.1 today. Area of triangles and quadrilaterals. There are three different ones we're going to talk about first. The first one is the area of a parallelogram. Now notice the parallelogram is the area equals the base times the height. Okay, now what is that similar to? A what? Ooh, not a triangle. Base times height is similar to like a rectangle. Rectangle is like length times width, right? Yeah. Notice here though, the height. We are talking true height, not slant height. Okay, remember, height is measured at a right angle. If it is a diagonal, you do not measure that height. Does everybody understand that? Yeah. Do not measure that height. Second one is a triangle. Triangle is area equals 1/2 the base times the height. Can anybody tell me why it's 1/2? Why is there a half included? Mr. Goldap. Half of a parallelogram, a rectangle. Nice job. Yeah, if I kind of close that over there, I get a rectangle. Well, that triangle fits in half of that, so that's where we get it. And then the trapezoid. The trapezoid is 1/2 the bases added together times the height. And again, I like to say the average of the bases times the height is just another way to say that. Okay. And again, why is it the bases added together? Well, really, because if you were to kind of cut this all off about wherever that midpoint is right there and fill it in, that's what you're finding right there. Okay. So today we're going to be looking at a lot of different things. For instance, the practice problem here. Find the perimeter of the rectangle in which area is 27 millimeters squared, and I have a width of 3. Well, how do I find the height of it then? I would divide. I divide, find the height to be 9. And then the question said, though, find the perimeter. Well, to find the perimeter, well, the opposite side is 3 and 9. I add them all the way around, and I get 24 millimeters. Okay, so not everything we're doing today is going to be just one step when you're done. Make sure you go back and answer all the questions. Let's look at number 1. It says, find the area of the parallelogram. Now, the formula of a parallelogram is area equals the base times the height. What is the base here, Hannah? And the height, Hannah? So what do I need to do to find the area, Hannah? I'm just going to multiply 6 times 10. My area comes out to be 60. And because I'm talking about area, it is units what? Squared. So my answer is 60 inches squared. Nice job. Correct, sir. Number 2. The base of the rectangle on which the area is 136 millimeters squared. So the area, that's the stuff on the inside, is 136 millimeters squared. How can I find the base here then? What do I have? Martina, what do I do? Divide. Yeah, divide. 136 divided by 8. And when I divide those, I get what, Martina? I get 17. Now, because I'm talking about length, it's 17 what? 17 millimeters, not squared. Squared is just when we find the area. Recognize that. See, I had the area there. What about number 3 here? The area of the trapezoid. What's the formula for area of a trapezoid? Formula. Give me the formula, Ryan. Nice job. So when I work that out, Nikki, what do I get, sir? I get 90. Is that what you get? Okay, so making sure. I get the area is 91 meters squared. Now here's the key. It's the average of the bases. So take 11 plus 15 and you get 26. Then take 20 and then do what with that 26? Half. So really I get 13 times 7 then. Or if I wanted to, you could also take half of the height if that's easier for you to compute. Okay, you just have to take the half in there at some point. Number 4. the height of the triangle in which the area is 192 centimeters squared. What's the formula for area of a triangle? What's the formula for area of a triangle, Mr. Boger?
Area equals 1/2 base times height.
Okay. Well, I want to solve for the height. So I could always just plug this in and solve for the letter I need to find. So for instance, the area is 192 equals 1/2 times 24 times h. Well, it's just like solving an equation here. Can I solve for h? What do I do with that half and that 24? What's half of 24? So I get 192 equals 12h. All right, now what do I do to solve for h? And my height has to be then what? 16 centimeters. Notice all we're doing here is including some algebra within our geometry. Okay, you're just solving for indicated variables. And again, you might have to go forward, you might have to go backwards, you might have to solve for something missing. Make sure you plug in your information with the correct formula. Take a couple seconds and try these two. All right, make sure you write the formulas down. Write the formulas down for the rectangle, write the formula down for the trapezoid. Number 6 is a little bit tougher. You can do it though. All right, let's look at this. Number 5. The perimeter of a rectangle in which the area is 154 inches squared and the height is 11. So I have a rectangle. The height's 11. The area is 154. Well, first of all, I need to find my base, right? Or my length, or my whatever you want to call it here. What is my base or length here, Nick? 14. Nice job. How did you get that? You divided, right? 154 divided by 11. But then I need to answer the question. The question says, what's the perimeter? What's my perimeter then, Ryan? 50 inches. Nice job. And I get that from adding up the sides around. All right, number 6 is the tough one. Who thinks they got the answer first? Mr. Nault.
Is it 4?
It is 4. Base 2 is 4. Good work, sir. And I would plug that in. So what happens here is you have the area of a trapezoid. A equals 1/2 base 1 plus base 2 times the height. So I get 5 equals 1/2 of 1 plus base 2 times 2. Now, remember, I can multiply any way I want to. So I would multiply the 2 and the 1/2 first. And what's 2 times 1/2 give me? 1. So I'm left with 5 equals 1 plus b2 because I don't need the 1. And base 2 then has to be 4. Nice job, sir. That is correct. Next thing we're going to talk about is the area of rhombuses and kites. The area of a rhombus is 1/2 d1 times d2. Now, what do you suppose d1 and d2 represent? Diagonal. Nice job. Diagonal 1 times diagonal 2. Now, what is this formula very similar to? The what formula? Anybody? Which area formula? Thank you. Look at the formulas on the other page. Which one is this one very similar to, Mr. Camden? Triangle. It's just like a triangle, isn't it? And what do you notice about the rhombus? When I do the diagonals, what's it cut it up into? Triangle. Yeah, it cuts it up into a bunch of triangles. So really the diagonals, and do half of the diagonals, it's just like I'm saying to find the area of a bunch of triangles. Same thing for kite. What do you notice about kite? It is the exact same formula. Hey, look at that. 2 shapes, 1 formula. Life is easy. Let's look at the example here. Find d2 of the kite in which the area is 156. Well, I plug in the area, 1/2 and 26. Half of 26 is 13. 156 divided by 13, I get 12 for my other diagonal. Pretty straightforward. Let's try number 7 here. Find each measurement. Number 7, the area of the rhombus. Well, area or the formula for area of a rhombus is A equals 1/2 d1 times d2. So that means I'm going to take A equals 1/2 14 times 10. Now, could I do half of 14 or half of 10? Or could I multiply them first and then take a half? Either way, at some point you just need to include the half. It doesn't matter when, at some point you do. What is the best way to do this mentally, would you say, Ryan?
I did 14 times 10, got 140, and multiplied by half and got 7.
Well, I guess you could do it that way. Anybody else do it another way? I would do half of 14. What's half of 14? 7. 7 times 10 is? I get 70 centimeters squared. Both ways get you the same answer. I don't know, I think that one's shorter because you have smaller numbers. Number 8. The diagonal 1 of the kite in which the area is 414 feet squared. Well, formula, A equals 1/2 the diagonals times together. So the area is 414 equals 1/2 23 times D1. Now, what happens if I do half of 23 here, though? I don't like decimals so much. Okay. So I'm trying to do this without a calculator. So what could I do instead? What can I do to move stuff to the other side?
Take half 23.
No, because that gets a decimal, sir.
Oh, yeah.
I can't subtract.
Divide.
What could I divide by?
414 divided by 20.
Yeah, I could divide both sides by 23 first. So 414 divided by 23 gets me what, sir? Yeah.
I got 36.
414 divided by 23 gets me what? So I get 18 equals 1/2 D1. Oh, not DI. D1. Now, how do I get rid of that half, though? I could do what? I would multiply by what? 2. Not multiply by a half. Multiply by 2. I could divide by a half, but dividing by a half is the same thing as multiplying by 2. Okay? So when I do that, then I get my other side, which is 36 feet. Nice job. Take a couple seconds, try numbers 9 and 10 on your own. Number 9. D2 of the rhombus in which the area is 90 meters squared. What do you get for the second diagonal, Drew? You get 12 meters. Nice job, sir. Again, you would do 90 equals 1/2 15 times D2. And you can multiply by 2 and divide by 15, or divide by 15 then multiply by 2. Either way. And number 10. What do you get for an answer there, Mr. Hardman?
Why did you get it squared?
Why did
you get it squared?
It's just 13 millimeters. That's better. Nice job. All right. Last thing we're going to talk about today. Well, what happens when we have some algebraic expressions? Uh-oh. Number 11. Find D1 of a kite in which the area is 16x. Yes, that does say x. Meters squared. And diagonal 2 is 8 meters. Well, again, area is 1/2 D1 times D2. So I'm using the same formula here. I'm going to plug in what do I know. The area is what here? 16x. So 16x equals 1/2 D1 times 8. Right? Is everybody good with what I did here? I just plugged everything in. What's a half of 8? So I have 16x equals 4 times D1. I'm going to solve for D1 here. What am I going to do next? Divide by 4. So 16x divided by 4, what does D1 have to be? What's 16 divided by 4? Okay. What else do I have included here then, though? My answer here is going to be 4x. Your answer is an algebraic expression. You have to include the variables on it as well. Take a couple seconds and try number 12. It wants you to find the area. You can do it. It's going to be an algebraic expression. All right, moment of truth here. Area of a rhombus in which D1 is 4AB and D2 is 7A. If you plugged it into the formula, what should it look like? Martina, what's it look like when you plug it in?
A equals 1/2 4AB plus 7.
Times 7A.
Yeah.
So I need to multiply them. Well, what's 1/2 times 4 times 7? What's a half of 4? 2. 2 times 7 is? So I get 14 Now I multiply the letters. What's A times A? And I have B. Can I multiply B with anything? Nope. So I get 14A squared B inches squared. Make sure you put your units on there as well.
So why do you multiply?
Why did I multiply? Because I could. That's the formula. Formula is 1/2 times the diagonals. So 1/2 times 4 times 7 gives me 14. A times A is A squared. And I get B. Here's your assignment.